gonna throw the ball way up and I'm gonna pause it and then I'm just gonna get the actual frame. So like let's say so it's 5 seconds. Check this out. It says 5, so this is gonna be real easy. And I'll just play it once it hits the ground. Okay, hit the ground. We'll go back to see where it hit the ground. So it's coming down and it hit the ground right there. So it's 6.31. So I started at 5, so that's 1.37 seconds. That's how I got the time. Now, at the end of the day, we just want the answer. So I found that the ball dropped 1.37 seconds. Now, how do I get the height? Well, height, the equation, is just time squared times 16.1. So if I take 1.37, square it, and multiply it by 16.1, well, guess what? I get that the rocket is 30.1 feet tall. And if you want to know more, you know what I mean? Stay tuned, because I go over it with a little bit of calculus, but I make it super simple. And here we go. All right, here we go. So acceleration, everyone knows. It's 9.8 meters per second squared. But that's all they know. But you know what I mean? But we're in America, so you should also know that acceleration is 32.2 feet per second squared. Well, hey, I know what a feet is, but I don't know what a per second squared is. So what's the definition of acceleration? Well, let's not do that. We're just going to go calculus first, and then maybe for another video, we'll bring it back in and go kind of simplified. But this is going to blow your mind. Acceleration, all right, is an equation. And, you know what I mean? And not what you think over here. Look at this. Okay, we're going to take this number 32.2. For you, it's just a number. But you know what I mean? Well, check this out. We're going to put the A for acceleration, and we're going to do this. We're going to go 32.2, and then we're going to go T to the 0. Okay, what's 2 to the 0? Well, that's just 1. What's 10 to the 0? Well, that's just 1, too. Okay, so right here, this is just 1. You know what I mean? That's the same thing as 30. But check this out. Now we can just use simple integration. I don't know if there's anything called simple integration, but if we integrate acceleration, hey, guess what we get? We get velocity. So velocity is just, you know what I mean, the integral of 32.2 t naught. I'm not going to write anything else except this integral sign. I don't want to confuse a damn thing. Okay, but then this is just 32.2 t to the 1. You know what I mean? Oh, but plus c. And for the simplest problem, your c is just 0. You know what I mean? So if you're like doing a problem, you're like, hey, this didn't work out, this didn't work, well, your c is something else. So we'll just get into that, but we're just doing the simplest thing. And now our position is just, hell, integrate that. So we got 32.2 t to the 1. Now what's that? Well, that's just 32.2 t squared divided by 2. Simple integration. You know what I mean? But then plus c. But hey, guess what? C 0. Why is C 0 for both these? Well, we're saying the ball is up there, and guess what? It's got no velocity. Velocity is 0. 0, the hero. It's not moving up or down at some point. Okay, so if velocity is 0, well, check this out. And then we're saying this is time. This is we're hitting the stopwatch. You know what I mean? Like right there. Like that's 0. That's 0 right there. That's 0. So when time's 0, hey, that's 0 plus, you know what I mean? So velocity is equal to 32.2 at time 0 plus c, but the velocity is 0. What's c? You know what I mean? That's c 0 too. That's 0. That's 0, baby. Okay, now position. Now we just got to throw an xy coordinate up here. Maybe our x is that direction, our y is that direction. I don't know. But this is 0, 0. This is 0, 0 right there. So our position at time 0. So now we go position. This is our equation for position. 32, no. Yeah, 32.2 divided by 2 at 0 plus c is equal to 0. Well, hey, c's 0 too. So that was real easy. So now we have, now our velocity equation is 32.2 t, and our position equation is 16.1 t squared. Well, isn't that what I just said height was? In my other video, I was just like, height is you take the time and square it, and then multiply it by 16.1. Well, that's how I got that. See? And just simple integration. But it all starts by saying acceleration. It all starts by saying a number, a single number, is an equation. And that'll just change your life. And now you can just do anything. You can literally throw the ball. You can start the ball up higher. You got the equation for velocity and position with this scenario. But let's say I was up at the top and I threw the ball down real fast. Well, before that, I'm down here and I threw the ball up real fast. My velocity is great. My velocity is greater than 0. So what's my velocity down here? Well, that velocity is the same as like when the ball hits the ground. So when the ball hits the ground, what's the velocity? Well, we just said our time to do this, and we clocked it. We never said it yet. Our time to actually do this whole rigmarole was 1.37 seconds. We captured the frame there, and then we captured the frame there. It was 1.37 seconds for the ball to start at the top and fall to the ground. So now we can just get the velocity, because velocity at the ground is just 32.2 times 1.37. And I've already done this. It's like 44. It's like 44.1 feet per second. It's about 30 miles per hour. 30 miles an hour. Okay. So let's say I just threw the ball. And guess what? That's how fast I threw the ball. I threw the ball 30 miles an hour up. So that's cool. So I could be at the top of this thing and throw it 30 miles an hour down. You know what I mean? And then what am I going to do there? Wait. But if I did that, if I threw the ball right up there 30 miles an hour down, this ain't our velocity equation, because we had this c, and now our velocity up here is equal to 32.2 t plus c, and we're just saying that's going to be a 44.1 feet per second. Well, now and that times 0, this is 0, but our c's got to be 44.1. So our new velocity equation for that scenario would be 32.2 t plus 44.1. And then if we integrate that, we get position, and that would be 16.1 t squared plus 44.1 t. And plus c, but c is going to be 0 because we're going to start up there anyway. So that's still 0, but because we threw it down, and now what do we know? Well, we know our height. We already solved for our height. If you solve this, if you put in 1.37 squared times 16.1, you get about 30 feet. You get 30 feet pretty much exactly. 30.1 feet. All right, we'll do it. 30.1 feet is what you get. So, okay, so now our position equation says when our position is 30.1 feet, 16.1 t squared plus 44.1 t. So now you can find the time. You got to solve for t. Is that hard? Yeah, you got to, you know what I mean? You got to scratch your head and think of what that equation is called. It's called like, you know what I mean? The quadratic equation. But then you get t is equal to like 0.56, say whatever. So yeah, that's the more complicated stuff. But we're just doing simple as. That's why at the end of the day, all I wanted to do was say, hey, your height is just take the time, clock it with a stopwatch, square it. You'll need a calculator for that, but multiply by 16.1 and just be done with it. You get the height in feet, and that's all we want to know in America, is how high is that thing in feet. Alright, that's a video. Alright, that's so crazy, because I even use this, you get an eyesight with a 45-degree angle from your eye, and then you use trigonometry. You got to add the height from your, from your eye to the ground. But I was standing at 25 feet, and doing the 45. So, yeah, that's kind of interesting. I was standing 25 feet away from it at a 45, so if I was standing, if I dug a hole in the ground that thing is only 25 feet high. But, you know what I mean? I guess it's real easy because I just add my height. Let's say I'm 5 feet to like my eye. So then it's 30 feet. That thing's only like 31 feet. Maybe even 32. That's surprising. I thought it was a lot higher.